Good morning, all of you. I am Mohammad Yasir from Department of Electronics Engineering, ZH College of Engineering and Technology, Aligarh Muslim University. My paper title is CNTFET based universal filter using DOCC2. Here is the outline of my presentation. First of all, I will introduce about this paper. Then I will give some overview about DOCC2, that is dual output second generation current conveyor. Then I will present simulation results for the DOCC2, and then I will present a DOCC2 based universal biquadratic filter, then uh, its results. Then I will provide a table which compares the filter characteristics with previously reported circuits, then conclusions, and then references. So introduction: a low voltage and low power dual output second generation current conveyor based universal filter using CNTFET technology is presented in this paper. The multi input single output, that is MISO universal filter, provides all the responses like low pass, high pass, band reject, and all pass responses in voltage mode. The operating frequency can be tuned easily by using the control voltages, implementing voltage controlled resistors. Since the circuit is free from resistors, it can easily be used in analog signal processing ICs, or you can say integrated circuits for high frequency applications. This is overview of DOCC2. Uh, this is the block diagram of the CNTFET based dual output second generation current conveyor. Its transistor implementation using CNTFETs. This is the characteristics of the equation of the DOCC2, and these are the different transistor sizes of this circuit presented in this table. Now I will provide some simulation results. Here in this slide we have DC characteristics as well AC characteristics for voltage and current transfer characteristics. In DC characteristics, what we have achieved is the linear behavior for voltage transfer is from minus 370 millivolts to 410 millivolts, while linear behavior for current transfer is from plus 160 microamperes to minus 160 microamperes. In AC analysis, what we have achieved is 3 dB bandwidth for voltage transfer gain obtained is 54.028 gigahertz, while the 3 dB bandwidth for current transfer gain is 48.846 gigahertz. These are the transient responses for voltage and current transfer action. These are the frequency responses of different port impedances. This is port Z impedance, port X impedance, this is port Y impedance, this is port Z plus impedance, and this is port Z minus impedance with respect to frequency. So what we have achieved is, as we know that the X port is the input port for current, so it must have very low impedance. So what we have achieved is 200 ohms of port X impedance up to 1 megahertz of frequency, and the maximum value is only 17 kilo ohms, which is good for cascading purposes. The port Y is the high impedance port because it is a voltage input port. It provides 500 mega ohms up to 2.5 gigahertz, which is good. Z ports, which is Z plus and Z minus ports, are output current ports, so they have they must have a high port impedance. So for Z plus it is 21 mega ohms up to 3.72 megahertz, while for Z minus port it is 15.8 mega ohms up to 4.47 megahertz. These are the block diagrams of the universal biquadratic filter using DOCC2, in which we have done, what we have done is we have replaced this physical resistor using a voltage control transistor. This equation provides the transfer function for the this circuit, and this table gives us how we can achieve low pass filter, high pass filter, band pass filter, band reject filter, and all pass filters from the same circuit. Okay, as this is a meso circuit. So if we put V1 and V2 0, then what we, and V3 is equal to 1, then we can have a low pass filter. Similarly, for high pass filter, we put V1 as 1 and the other two ports as 0, then we can have a high pass filter. Similarly, band pass filter. Similarly, band reject filter. Band reject filter, in I will put V2 as 0 and other ports are as plus 1 volts. Similarly, all pass filter, in all pass filter, what we have to do is we have to put V2 at 180-degree phase shift of the voltage. These are the equations for natural frequency as well as quality factor. These are sensitivity values for natural frequency and quality factor with respect to R1, R2 and C1, C2. They both have magnitude of half, and signs have different for both. That is, for natural frequency it is minus half, and for quality factor it is plus minus half both. For R1 C2 it is plus, for R2 C1 it is minus. In this circuit, we have taken C1 and C2 as 1 picofarad and controlled voltages. We have taken different values for different cases, as when we take 0.5 volts for C1 C2, VC1 VC2, the frequency of operation obtained is 14.79 megahertz, and in that case the total power consumed by the multifunction filter is 961.8 microwatts. These are the simulation results for the universal filter. This table provides us the varying nature of the operating frequency when we have put the VC1 and VC2 have with different values. We have achieved maximum value of operating frequency of 14.79 megahertz at VC1 and VC2 is equal to 0.5 volts. These are the responses of low pass filter, gain and phase, and this is the voltage gain for high pass filter at 0.3 volts of VC1 and VC2. Similarly, at the same value, we have here is gain and phase plot of band pass filter, band reject filter, and all pass response. These are the various responses of the universal filter when we have taken VC1 at 0.3 volt, which is fixed, and varying the value of VC2 from 0.25 to 0.5 volts. These are the various responses for gains of different uh, filters. That is, it is for low pass filter, it is for high pass filter, it is for band pass filter, it is for band reject filter, and it is for all pass filter. And this, what we have is we have combined the effects of all the filters in the same plot. That is, all pass, band reject, high pass, and low pass filters with respect to the frequency. This is when we have combined the low pass filter, high pass filter, and band pass filter for input transient value, input transient signal. This is the THD plot for band pass filter. What we have done in THD is a sinusoidal input of different magnitudes from 10 millivolts peak to peak to 200 millivolts peak to peak is applied at the input. The THD value is 7.535% for a significantly large amount of amplitude of 200 millivolts peak to peak input volt. This is the response for input and output noises with frequency. This is also with the for band pass filter. Maximum value of input and output noise is 704.6 nanovolts per root hertz and 4.536 femtovolts per root hertz. These are the Monte Carlo analysis for the band pass filter. We have done 100 runs for Monte Carlo analysis. This is voltage gain of band pass, this is phase response for band pass, and this is histogram. Here we can see that the 14.7 megahertz 79 megahertz is the standard value, and what we have achieved is the mean is 14.75. It is very close to the value, and the variation is also very low, that is 0.34 megahertz. This table provides the comparison with the different circuits in the literature. These values are for our work. What we have is we have two DOCC2, two capacitors, and two switches of the transistors. We have no resistor. It is also have no resistor, but this and this reference have resistances. Capacitance, this circuit is also free from resistor. So all of them except this one provides all the responses. These are the supply voltages. We have taken lowest value of supply voltage. The power dissipation data is not available for these three, so we have compared only with two. It is a bit smaller than us. Technology notes these two papers, our work and this reference 8 has CNTFET. Others have, these two have CMOS of 0.18 micrometer and 0.45 micrometer, and this one is based on BJT. The tuning range is greatest in this reference, while our circuit is also providing a good combination of the tuning range. Others, this is very low tuning range, 109 kilohertz to 202 kilohertz. It is also only 1.59 megahertz. This is good. It is providing a good value of tuning range. So we have concluding our paper. A CNTFET based DOCC2, and based on it a voltage mode meso universal biquadratic filter is presented. From a single topology, the voltage mode universal filter provides all the filter responses, that is low pass, high pass, band reject, and all pass filter responses. The operating frequency can be tuned easily by using the controlled voltages, implementing voltage controlled resistors. Since the circuit is free from resistors, it can easily be used in analog signal processing ICs for high frequency applications. These are the some of the main references which we have used in our circuit. Thank you.